we've got ourselves enjoyed.
Masterton, New Zealand, March 2012. In a quiet, dead-end street, a man runs outside with his camera after a major storm.
Have you ever had this in your town? Eels. Eels in the gutter.
The street is full of live, swimming, freshwater eels. Jermaine Carahy is a witness to this extraordinary sight.
When I got here, there was actually eels swimming in the gutter. I looked down to my left, there was a couple down there. There was, they were actually swimming on the footpath.
Look at it. Eels on the road.
When we got out and actually saw that there was eels swimming around, yeah, it was a bit of a shock. So first time I've ever seen that in the streets.
How can a dozen eels find their way into a suburban street? It's down to an exceptionally heavy rainstorm that hit the previous night.
I just remember the night before, it was raining at least 24 hours non-stop.
Meteorologist Randy Cervini studies these intense weather events.
To create the conditions to have eels come up a street, we need to have a very specific weather event. In the case here, it was what's called a cloudburst. Some people call it a weather bomb, if you will. In essence, a very intense thunderstorm that dropped an immense amount of rainfall in a very short period of time over a very localized area, enough to cause very severe flash flooding.
When a weather bomb hits, there is so much rain the local drainage system can be overwhelmed. The result is a flash flood, where instead of carrying the water away, waterways back up into drains, drains overflow, and water rushes into the streets. The flow can become so strong that living creatures are washed into the streets too.
They actually came through this drain here. This drain runs to a creek at the back of the house that my grandmother lives in.
After seeing the eels, Jermaine's grandmother asks him for some help to make some traditional New Zealand cuisine.
My nan actually was encouraging us to go out there, catch them, so she could eat them. But she's old school, so she was keen to have a nice feed of eel.
But luckily for the slippery sea snakes, Jermaine has other ideas. Instead of cooking them, he releases the eels into a local creek.
Is the eels, people? Told you we were releasing them, we didn't eat them.
So the next time heavy rain is forecast, think about grabbing a fishing rod instead of an umbrella. Machinchao, Argentina, December 3rd, 2011. Photographer Alfredo Ristal spots a strange formation in the sky. It looks like an old man's handlebar mustache. He grabs a few shots of this whirling, wispy object. Then, after about 30 seconds, it disappears. This is one of the world's rarest clouds, a mustache cloud. Meteorologist Mike Chalinas loves these clouds.
Anything involving the mustache, and you name a cloud after it, it's a 10 out of 10 in terms of what it looks like. A 10 in terms of its rarity, too. I've never seen one, and I don't know anyone that's ever mentioned to me that they've seen one. So they don't happen very often.
One reason they are so rare is that wind conditions have to be absolutely perfect to create one.
A mustache cloud is essentially a little cumulus cloud that drifts over an updraft. And that updraft kind of bends the cloud, and then we have an horizontal axis that the cloud is kind of spinning on.
It's this spinning motion, a vortex, that allows these clouds to hold their distinctive shape. Hence, they are also called horseshoe vortex clouds. Vortices can be highly destructive, but this one is so weak, it sometimes lasts just a few seconds. Another reason this cloud is so hard to spot.
Most people, when they think of spin in the atmosphere, they think about vertical spin. The mustache cloud is created by horizontal spin. And because of that, it's usually not going to be as intense as a vertical type vortex.
That makes this video from Argentina truly exceptional. A rare moving image of one of the rarest clouds in the world. Coming up, a tornado made by a volcano.
As a scientist, it'd be impossible not to be obsessed with them.
How spring rains make a monster that grows out of control.
It was so large, we could see it with satellites.
And the cloud that helps people fly.
You could equate it to a magic carpet ride. As close to being a bird as I know.
Number one, meteorologist Mark Thibodeau. Thanks for staying with us. We continue to track Hurricane Maria moving through the western Atlantic, now north of the Turks and Caicos Islands. It's still a Category 3 hurricane. Winds are 125 miles an hour. Where is Maria going to go, more importantly, as we head through the next several days? Looks like it's going to continue to track northward a little bit. And you can see the left side of the cone where the center could go is a bit further towards the U.S., the right side a little further away. The best computer model estimate right now is down the middle somewhere, staying offshore, but introducing quite a rip current risk and surf risk to the northeastern U.S. Here's the latest computer runs here, and you can see that most of them keep it offshore. A trough moving in from the Midwest is going to pick this up in all likelihood and take it out as we head later into next week.
Qingdao, China, July 2008. As China and the world prepare for the Beijing Olympics, this city, home of the sailing events, faces an unusual problem that is literally growing out of control. A green bloom is spreading across the bay, and it's caused by the weather.
Because it extends to 1 kilometer, you can't escape.
The green bloom is thought to be a kind of algae called sea lettuce. To get rid of it, the authorities organize a massive cleanup effort. Volunteers, boats, and heavy lifting gear shift more than 1 million tons of this green slime out of the sea.
到海边泡泡游泳的，结果这样的情况就不敢下嘛。我觉得很脏，就不敢下去。
But while some beachgoers stay away, others dive right in. They may seem crazy, but this kind of algae causes no danger to human health. In fact, not only is it harmless, it's tasty. University of Southern California's Rafael Cudella studies this gooey green stuff.
An algal bloom, the site of it is often a discoloration of the water. It can be brown or red or orange or even bright green. It's often got that briny sea smell. In eastern China, there was a particularly large bloom of this green algae that ended up actually floating around out in the open ocean.
So what kind of weather causes the bloom to grow to such an enormous size?
What we think happened is that China has been using a lot of fertilizer. That's been running into the ocean, and at the same time, they're doing what's called mariculture. They're growing algae on these rafts. And so the combination of the fertilizer and this algae that accidentally was released from these rafts, we ended up with these great big mats of algae.
The fertilizer that feeds the algae actually comes from farms on the land. But it's really the rain that turns this into a classic case of strange weather.
When it rains, that fertilizer, if it hasn't been taken up, it just washes out into the creeks and into the ocean. And the algae in the ocean are just like plants on land. They love that fertilizer, so the more of it you give to them, the faster they grow.
It's not just China that has to face green blooms. There's also an American green bloom that regularly colors the waters of our Great Lakes.
That water is green, and not just a little green. It's like pea soup green.
In 2011, a bloom on Lake Erie gets so large, it can be seen from space.
So Lake Erie used to be a very popular place to go in the summer as a tourist and just enjoy the beautiful lake. But as we've had more and more of these blue-green algae blooms, people don't want to go there because there's a sort of blue-green scum. It's piling up on the beaches.
Cleveland, Ohio resident Zen Archer is a witness to this mega bloom.
I've lived in Cleveland all my life, and I'd never seen anything like that in the lake before. There is nothing but green, yucky algae everywhere.
And unlike the Chinese bloom, the algae that appears on Lake Erie is not nutritious sea lettuce. It's a species called blue-green algae, which can cause serious health problems.
Blue-green algae are causing a big problem in Lake Erie because one of the things that they produce is this compound called microcystin. And microcystin is this very, very dangerous toxin that if you can tax your liver.
But in both cases, the main culprit is the weather in the form of spring rains.
Scientists have discovered that the spring rains are a really good indicator of how big the blooms are going to be in the summer. And so the more spring rain we get, the more fertilizer that comes into the lake, the bigger the bloom is going to be later on in the summer.
Zen's personal experience backs up the scientific evidence.
It had been rainy, but also very, very warm. Combined with not a lot of wind or air resulted in this algae proliferating and filling the water.
Experts in both China and the U.S. are working on ways to prevent these massive green blooms in the future.
Certainly you could improve the situation in Lake Erie by reducing fertilizer runoff into the lake.
But in the short term, beachgoers in Qingdao are likely to be munching their way through a lot more sea lettuce. The Kilauea Volcano, Hawaii, August 2008. Tourists watching lava pour into the Pacific see a twisting vortex emerge. What causes this mini tornado on a perfectly clear day? Storm chaser George Karunas explains.
At these ocean entry points, especially at Kilauea Volcano, you can sometimes, when the wind is just right, get a vortex that looks like a mini tornado that forms right where the lava is entering the ocean. It's a steam devil, very similar to a dust devil that forms on a hot summer's day.
At the Denver Museum of Nature and Science, curator Jennifer Moss Logan shows how this works.
What we have here is a box. It has slits in the side to allow air in. Right here is a hot plate, and on the hot plate are coins. Those coins represent the lava. What I have here is a little tin of water. This water represents the ocean water. Let's see what happens when we add the ocean water to the lava.
When water and hot lava touch, steam is released, which starts to mix with cold air around it. More air is drawn in from the surrounding area, creating a circular air current that spins the escaping steam.
That rising column of steam, that's the vortex. The air is rushing in and circulating around and causing that beautiful vortex. That is our steam devil.
They can be quite large, and they look like a waterspout that you might see in the Florida Keys or perhaps on the Great Lakes, but it forms under completely different circumstances. A waterspout is a column of air that's being stretched by a cloud that's starting to billow up, and it looks very similar to what's happening here at the volcano, but it's quite different.
Vortex expert Reed Timmer has long been interested in these terrific twisters.
What I find fascinating is just the rarity. You can't really find them in many places across the world. This is the only known place that I know right now where they happen that consistently.
But the truth is, you don't have to fly to Hawaii to see a steam devil. These are steam devils on the Sangamon River in Illinois. They are more than 4,000 miles from Kilauea, but they are formed in exactly the same way. The only difference is the water here is heated by the sun instead of hot lava. Whether the process is driven by molten lava or a warm summer evening, steam devils are a beautiful example of strange weather.
When you're combining something as interesting geologically as a lava flow and then something as meteorologically interesting as a water spout, as a scientist, it'd be impossible not to be obsessed with them.
Next, is this the most powerful lightning in the world?
If a Superbolt hit a house, I would not want to be in it.
And the wind-driven wave that sinks a whole town.
After the floodwaters had cascaded down through this village, they decided that it was easier to abandon the village than it was to rebuild the dam.
Hey, welcome to my channel.
Woodward, Oklahoma, May 27, 2001. Two storm chasers are driving along a barren highway when they spot this. A lightning bolt that lasts for almost 3 seconds, surging with 100 times the power of an ordinary strike. This is a Superbolt.
That's the longest I've ever seen, mate. Got it?
I got it.
Lightning expert Joe Dwyer explains more.
We've known about these Superbolts for decades. We're still not certain exactly what they are, whether it's an observational peculiarity or it's actually something to do with how lightning works. Superbolts appear to be on the rare end of the spectrum. It's not quite clear how rare they are, but they seem to be just on the right at the tail of what lightning can do.
Experts believe that superbolts may make up fewer than 1% of all lightning strikes. However, this extreme form of lightning can strike anytime, anywhere. They have been seen all over the world, from Paris, Texas, to Paris, France.
We can see distribution of little lightning and big lightning from most thunderstorms. I would say that any thunderstorm could potentially make a very big Superbolt.
Although we know relatively little about superbolts, what we do know suggests they are possibly a form of lightning called positive lightning.
Like sort of two flavors, positive and negative. When you look at the real big stuff, that all tends to be positive, and so the inference is the superbolts also would be positive lightning.
Negative lightning is the more common form and tends to come from the bottom of a storm cloud. Positive lightning is rarer and usually comes from the top or anvil of the cloud. It is more powerful than negative lightning. While it is possible that superbolts can be either positive or negatively charged, it is certain they are the rarest and most powerful of all.
Personally, I find superbolts kind of scary. If a superbolt hit a house, I would not want to be in it.
Epecuén, Argentina, November 5th, 2011. A group of photographers come upon a bizarre sight, a ghost town on the edge of a lake. This is Villa Epecuén. In the 1960s and 70s, Epecuén is a thriving lakeside resort, attracting up to 20,000 people a year to enjoy the mineral-rich waters of Epecuén Lake. But in 1985, a flood completely destroys the town, drowning it under more than 30 feet of water. The flood is caused by a rare weather event, a Seiche wave. Randy Cervini explains.
This lake had a particular property that if you blow the winds in a particular direction over this lake, it will create a wave that will amplify over the volume of the lake. It's called a Seiche wave. We have them also in places in the Great Lakes.
A Seiche wave is a wave that forms in an enclosed body of water, such as a lake, a swimming pool, or even a cup of coffee. When the wave hits one edge of the water, it is reflected back to the other side, and then back again, and again. Add in a strong wind, and the wave's power is continuously charged up, giving it great destructive potential.
It's a pretty rare event because you have to have exactly the right configuration of the lake and a very strong wind.
The 1985 Seiche wave that destroys Epecuén becomes so strong that it smashes through the dam that protects the town. With no defenses, the wave carries on, submerging the town completely.
So after the floodwaters had cascaded down through this village, they decided that it was easier to abandon the village than it was to rebuild the dam. So this town was left as a ghost town, and it was left to stagnate in the waters of the flood.
Epecuén is submerged under the waters of the lake for more than 2 decades, lost like an Argentinian version of Atlantis. But by 2009, it miraculously reappears.
Over the last 20 to 30 years, these waters have slowly receded, and we're starting to see these buildings reemerge as a kind of eerie ghost town, a kind of eerie remembrance of what used to be a thriving, prosperous town.
Nowadays, the town has only one permanent resident, 83-year-old Pablo Novak. He used to live here back in the day. And when the waters receded, he moved back into his old house. He's a witness to one of the strangest weather events in history. Coming up, how a summer day can get so hot it melts metal.
In some cases, they've reported of 196 degrees Fahrenheit.
And the narrow cloud that fills the whole horizon.
Isn't that wicked, honey? That's unreal.
our models, just slightly different to give us an idea of what the spread is in the atmosphere with the
London, England, September 3rd, 2013. It's a blazing hot summer day, and on one street corner in the heart of the old city, it gets so hot, a car starts to buckle and melt. Nearby, the welcome mat of a barber shop catches fire, and a plastic lemon in the window starts to bubble and warp. How can this happen in a city where the all-time record high temperature is just 100.6 degrees? The answer lies with this skyscraper known locally as the Walkie-Talkie, under construction across the street. For 2 weeks each year, its curving facade acts like a giant mirror, magnifying a hot day into, quite literally, a scorching one. Randy Cervini is intrigued by this story.
In the situation here in London, what we see happening is where they weren't realizing it, but they were focusing sunlight as a result of this skyscraper. Unfortunately for the car owner, that reflected sunlight off of the skyscraper was concentrated down into a beam that actually reached a surface temperature, in some cases they've reported, of 196 degrees Fahrenheit.
The
I want to get you the very latest on a tornado cloud.
A media frenzy.
Honestly, you do not want to be here right now. It is the hottest I have ever felt in London.
For several days, people camp out in this ultra-local hotspot. They film the damage, measure the temperature of the asphalt, and even fry eggs in the concentrated sunlight. And this is not the only skyscraper that acts like a giant concave mirror. A luxury hotel in Las Vegas, designed by the same architects, also creates a concentrated heat ray that scorches vacationers lounging by the pool.
My head was steaming hot. In fact, my hair felt like it was burning, and I could actually smell my hair burning.
In both cases, the building's owners are trying to correct the problem, or at the very least, provide some shade to the worst affected areas. Sea Isle City, New Jersey, June 7th, 2012. Resident Phil Walsh records an ominous cloud rolling down from the north.
Whatever that front is coming across there, looks like a real bad boy.
It is perfectly barrel-shaped and appears to fill the entire horizon. This is a roll cloud.
It's very unusual. Huge clouds.
15 months later, Northern Virginia resident Jeff Krull captures another roll cloud on his way into work. The National Weather Service will later post these dramatic pictures on social media. Wherever and whenever these clouds appear, they seem to attract a lot of attention.
Isn't that wicked, honey? That's unreal.
At the University of Colorado Boulder, Katja Friedrich studies these extraordinary formations.
Roll clouds form when warm and cold air meet. So as the cold air moves in, the warm air is being pushed up and over the cold air. And as these two air masses mix, they form these roll clouds.
A mass of cold air will often spread out over the Earth's surface like a glass of spilt milk. When this advancing cold front meets a mass of warm air, the warm air is forced upwards, where it loses heat and falls back to Earth again. This rising, cooling, and falling action condenses water vapor, a gas, into droplets of liquid water, forming a visible cloud. The advancing cold front also pushes this rising and falling warm air forward, creating an invisible wave of air that literally rolls the droplets up into a distinct cigar-like formation. Although many people find roll clouds a little frightening, one particular group of people can't wait for them to appear. John Hesh is one of them. He's a hang glider pilot, and he loves roll clouds so much that every time he sees one, he tries to jump right into it. In October 2011, he captures this amazing footage of a roll cloud while soaring above it.
That day was special because I watched the cloud grow and develop and extend all the way up here, and flew it for an hour and watched it dissipate and disappear.
The reason John loves roll clouds is that they help him defy gravity.
When we fly a hang glider, we're constantly sinking at 200 feet a minute, but when the wind blows hard enough, it counters that sink rate and we can fly around as long as the wind blows.
Roll clouds create exactly the kind of wind that can keep John aloft for extended periods. At the front edge of every roll cloud, there's an updraft of air. As long as he stays in front of it, he can stay in the sky.
It's a visible highway in the sky. It defines the lifting area. As close to being a bird as I know. When they appear, it's a magical afternoon.
John first experienced a roll cloud flight in 1991, and since then, he's flown roll clouds at least 5 times. But even cloud lovers with their feet on the ground know that when a roll cloud appears, it's a rare and beautiful weather event.
And a good evening, everyone. Meteorologist Mark Thibodeau, thanks for staying with us. We continue to track Hurricane Maria in the Atlantic. And now moving north of the Turks and Caicos, still looking at some pretty heavy rain bands moving across this area down to the south around the circulation with Maria. More importantly, where is this storm going as it heads through the Atlantic? Looks like it's going to be heading north as a major hurricane through Saturday afternoon, then maybe weakening a little bit as it encounters cooler water temperatures that are located up here across the north part of the Atlantic and down to a Category 1. It could go either side of this cone, but the important thing to remember is either way, it's going to be sending some swells and rip currents up into the Atlantic seaboard through Saturday afternoon, then maybe weakening a little bit as it encounters cooler water temperatures that are located up here across the north part of the Atlantic and down to a basically take it off to the north. There is a trough of low pressure located up in the Great Lakes, which should sweep it out as we head through the middle of next week, but we're going to keep an eye on these trends.
We have uncovered a remarkable planet, a world of extreme weather, alien landscapes, and bizarre phenomena. It's the most complex system we know of in the universe. That planet is Earth, and we are only beginning to unlock its secrets.
You're walking along, and there on your horizon, suddenly there are 3 suns? What would you make of that?
What forces can put 3 suns in the sky? Or set fire to the night? Or create a tentacled monster above a thunderstorm? You are about to witness the most amazing 24 hours on Earth. As cities float in the air. As the sun flashes green. As wind from space collides with the power of the planet's core, and we solve the mysteries of Earth's strange skies. On planet Earth, some of the strangest secrets are hidden in a very familiar place. The sky.
The sky is the interaction of light from the sun 93 million miles away. It's clouds interacting with water and air. It's everything that we see above the horizon. The sky begins at your feet. We live in the sky.
In 24 hours, a single turn of the planet, you can witness some of the strangest sights in the universe, if you know where to find them. We start the clock just as night falls, in the middle of a thunderstorm over North America's Great Plains. The lightning is bright, but it's a common occurrence, striking somewhere on Earth 50 times a second. The real mystery is what happens above the storm. Weird apparitions that for generations were dismissed as unreal. Fiji, 1950. An airline pilot is startled by a mysterious red flash above a storm cloud. He describes a burst of light like a firework display, spreading out like a water fountain. Despite the pilot's rock-solid reputation, few believe his report.
A pilot is a pilot. He operates the aircraft. They're not up there observing science. They're not up there observing the atmosphere.
For decades, mountaineers, balloonists, and pilots had made similar reports of strange lights in the skies, with the same results.
Scientists probably just discounted it. They just didn't find it scientifically important enough to actually commit research to it.
The sky flashes were the stuff of rumor until July 6, 1989, during a ferocious storm over northern Minnesota, when a new, highly sensitive camera happened to be aimed above the clouds.
Some scientists discovered the first photographic evidence of what pilots had been observing for decades.
A glowing creature in the sky, like a jellyfish 6 times the size of Mount Everest, that appears and vanishes in the blink of an eye. The photograph spurred a worldwide hunt for more of these creatures of the upper air. More were found. Some looked like carrots. Some all red and up to 35 miles tall, and they all lasted less than a second. Scientists named the flashes sprites, after the legendary fairies that appear and disappear without warning. Their briefness had made them hard to see and easy to brand as mere illusions. But it became clear that what was once thought of as empty sky was a realm of secret monsters brought to life by lightning.
A sprite is an electrical discharge in the atmosphere during very vigorous lightning storms, but they're not like a lightning bolt.
A regular lightning bolt flashes below the cloud. Sprites form 25 miles or more above the cloud. A searingly hot lightning bolt is white. A sprite is red. But the red sprite shares a surprising secret with traditional lightning. The hottest naturally occurring thing on Earth is formed in one of the planet's coldest places, inside a thundercloud, where it's as freezing as the Arctic, and water becomes crystal.
The ice is the secret of lightning.
The ice crystals that are hitting each other in a cloud become charged. The positively charged crystals tend to be lighter, so they're taken up with updrafts, and the negatively charged, heavier parts tend to be near the bottom of the cloud. So typically, the bottom of a cloud is negatively charged, the ground below is positively charged.
An energy path is opened, and ice makes fire.
Inside a thunderstorm, the temperatures are below freezing, but you have a spark that can be more than 5 times the temperature of the surface of the sun.
But how does the force that makes lightning also create sprites? By turning a negative into a positive. Normally, positive charges gather on the top of a thundercloud and negative charges at the bottom. So most lightning bolts have a negative charge. But 1 time in 10, a positive bolt creates a negative electric field above the cloud. So the charge goes up, energizing nitrogen in the upper atmosphere, creating a red glow. But over 30 miles up, the air is too thin for the charge to hold together. It dissipates, forming strange shapes. But red sprites aren't the only strange sights above the thunderclouds. A blue jet, lightning from a cloud that goes up. Blazing out of the top of a thundercloud, blue jets shoot upward in narrow cones. In 2/5 of a second, a blue jet can stretch 10 miles into the sky. Impressive, but not compared to a gigantic jet.
A gigantic jet is a blue jet on steroids. They're rare, occurring in very tall thunderstorms that are very strong. A gigantic jet can go all the way from the top of a cloud to the base of the ionosphere, which is 60, 70 miles up.
Big as they are, jets and sprites are small compared to elves. Elves are triggered when an especially powerful burst of lightning creates an electromagnetic pulse that rockets up more than 60 miles, causing gases to glow at the very edge of space. Elves move at almost the speed of light, ballooning out from nothing to a disk 300 miles across in 1,000th of a second. They weren't discovered until 1990, after researchers examined films of thunderstorms taken from the space shuttle. Elves, sprites, and jets have shown that Earth's skies are far stranger than scientists once imagined. As the thunderstorms fade and the night deepens, another strange vision, believe it or not, this city on the horizon isn't really there. In our 24-hour tour of Earth's strange skies, the planet has turned from late afternoon to the middle of the night. Half the world is in darkness. And where the night is warm and clear, conditions are right for one of the strangest skies of all. May 11th, 2012. On most nights, when the people of Grand Haven, Michigan look west, they just see the waters of Lake Michigan and the stars in the sky. But on this evening, there's an eerie sight. The lights, not of stars, but of a city, floating in the night. It's a real city, Milwaukee, Wisconsin. But Milwaukee is 80 miles away, beyond the curvature of the earth. Grand Haven and Milwaukee can never see each other. Or can they?
Standing on a lake shore, or maybe on an ocean beach looking out to sea, it's natural to wonder how far you can see. Typically, it may be only a few miles. There, your vision is stopped by the curvature of the earth. You can't see over the horizon, but on a few days, when the conditions are just right, you can see the impossible.
To make a city float in the sky, you need light and layers of air with different temp called a superior mirage. Superior because the image comes from above.
In a superior mirage, the Earth's atmosphere bends that light and into our sight line, so you can sort of see things that have already set beyond the horizon.
Well, this was spring. The sun had been heating up the air, but the cold water of Lake Michigan was cooling the air right above the water. So you had a temperature inversion, which meant that as the light left Milwaukee and passed upwards, as it encountered this boundary, it refracted back downwards to the people in Grand Rapids. And so standing there along the lake, you could look out and see the lights of this distant city that you'd never been able to see before.
What actually happens normally with light is that it travels in a straight line through the atmosphere. And so this laser beam goes straight from here to our screen over there and makes a little dot. But when there's a variation in the temperature of the air, the light can bend in different ways. So when I move the dry ice in front of the beam will actually bend toward the colder part of the air, so it'll bend downward. And so our spot on the screen will move down compared to how it was without the ice. And so light moving across the surface of the Earth actually bends downward toward the colder air. And so it makes faraway cities beyond the horizon actually appear visible.
A century before, and 3,000 miles to the north, there was another startling sight on the horizon. Axel Heiberg Island, the Arctic, June 1906. Here, where the days and nights can be 6 months long, explorer Robert E. Peary sees a vast land of snow-capped mountains and valleys in the distance. In 1913, another expedition is sent to map the new land. Following Peary's directions, they see the mountains and valleys, but the Inuit guides say it's all nothing but mist.
The Inuit, they knew these lands didn't exist because, well, they'd been there.
Ignoring the Inuit, the Americans press on. But over the days, the land shifts and changes its form and size.
These explorers went in search of land there over the horizon, land that simply doesn't exist.
It was either glaciers or icebergs or something that were visually lifted relative to the expedition.
Even today, the Arctic is full of imaginary landscapes that look real. But they're an extreme version of a superior mirage called a Fata Morgana.
In the Arctic or the Antarctic, you have ice along the ground, which keeps the ground level air very cold. Above it, especially in summer where the sun never sets, the air above can be quite warm, and so you get a temperature inversion. Because those conditions stay constant like that, people can go back year after year, decade after decade, and see those similar, strange, mysterious lands that really do not exist at all.
You don't have to go to the ends of the earth to see a Fata Morgana. But where the temperature constantly changes, the mirage only lasts a short time.
First time I ever saw a Fata Morgana was sitting on the beach in Southern California looking out into Catalina Island. And one day I looked over, and where before there'd always been this nice little gently sloping island, on this one occasion were these huge cliffs, and as if the island itself had suddenly transformed into something different.
I've observed mirages where it looks like there's distant mountains that just don't even exist.
A Fata Morgana, or a superior mirage, is a sight no one can ever forget. But there are even more amazing sights up north, where the black of night is banished by some of the strangest skies anywhere on the planet, thanks to winds from outer space and power from the center of the earth. Our 24-hour tour of Earth's strange skies has reached midnight. And in the frozen north, the skies are alive.
I was in Alaska toward the end of the summer, and I just saw wisps of green, and I thought, oh, wow, what's that yellowish green? And then I realized, wait a minute, that's the aurora.
Seen from space, it looks like a crown of energy around the top of the planet. From the ice floes and fjords, it looks like a dazzling curtain of light.
Growing up in Alaska, standing at the bus stop in winter, I'd be there 3 hours before the sun would rise. But on certain mornings, you'd get the aurora. And it was like seeing this dancing light show across the sky. And there, it'd go from white to green to red.
They're called the Northern Lights, but they're seen at the South Pole too.
If you were to look down at the planet as a whole, you'd see the light concentrated at the North and South Poles in rings of light.
Even the northern lights can stray south. February 1872, the aurora lights spread down the sky as far as Cuba, and thousands take it as a sign of the end of the world. What power creates such a phenomenon? It turns out that the aurora's beauty begins with a stream of deadly energy, charged particles from the sun called the solar wind.
The solar wind is actually the sun's atmosphere that is constantly burning off and exploding out into space. And that blows at us as a constant solar wind.
Streaming across space at nearly 1 million miles an hour, the deadly radiation would render Earth as lifeless as the moon. But it doesn't, thanks to a planetary defense system that begins thousands of miles underground. In the center of the Earth is a solid iron core the size of the moon, by an outer core of molten metal the size of Mars. As the liquid core spins, it creates a magnetic field that extends through the Earth and tens of thousands of miles out into space. It is a shield against the sun's attack.
The magnetic field is a great force field for our planet.
But the power of the wind distorts the shield.
The solar wind deforms the Earth's magnetic field because it's a wind that's blowing from one side relative to the Earth's field. And if the wind is blowing on one side, it's going to actually push one side and it's going to elongate the other side out like a comet tail.
Some of the charged particles of the solar wind collect in the stretched out tail. Like a slingshot, the energy builds up in the tail until it has to be released.
Solar wind particles get deflected perpendicular to how the field is projecting out from the Earth. So that pushes them to either the North or the South Pole.
I think of magnetic fields kind of like lanes on the highway. When you're in a car and you're going to get off the exit ramp, you have to go where the ramp goes. You can't just go anywhere you want. So charged particles get sent to the poles. When they reach the poles, though, most of them bounce back and go to the other pole and oscillate between the North Pole and the South Pole, back and forth, many, many times a second.
Sometimes particles don't get back on the highway. Like a traffic accident off the exit ramp, they collide with gas atoms and molecules, and the energy lights up the polar sky. The color depends on what gets hit.
Oxygen typically gives off a brilliant green color. Nitrogen gives off a red color.
The process behind the aurora is visible in any city on Earth, in neon signs.
You can actually look at neon lights as kind of like aurora in a bottle. You have this gas that has electricity flowing through it, essentially electrons that are flowing, and when they actually impact any of these ions, it excites these ions into a higher energy state, and that gives off light. And the same exact process is occurring up in the upper atmosphere.
The power that creates the aurora lights up the poles. But auroras are also seen in places you'd never expect.
And a good evening, everyone. Meteorologist Mark Thibodeau, thanks for staying with us. We continue to track the tropics tonight. Hurricane Maria, still a major hurricane in the Atlantic, now passing north of the Turks and Caicos. Winds 125 miles an hour, pressure 953 millibars. Moving off to the north-northwest at 9 miles an hour. Forecast track is to take it up to the north a little bit, and then more of a turn to the north and northeast as we head into early next week. Expected to stay a hurricane. You can see the left side of where the center may go is a lot closer to the U.S., the right side a little further away. Most of the computer models take it on a track to the north, and then it is expected that there is a cold front moving into the northern plains, that will move in a bit later on in the week and take Maria out further into the Atlantic, and that would be good news. In the meantime, watch out for the rip current risk. It's going to remain high from Boston all the way down to Ocean City this weekend.
The 24-hour journey through the strange skies of Earth passes midnight and heads for dawn, as the battle between the planet's protective magnetic field and the energy of the solar wind lights up the poles. But this battle also happens on other planets throughout the solar system. That's because if a planet has a magnetic field, like Jupiter, Saturn, or Neptune, it has auroras.
Very few people realize that there are also moons that have aurora as well. For instance, one of the moons of Jupiter is Ganymede, and Ganymede has its own intrinsic magnetic field, and it has aurora happening all the time.
More than anywhere else, though, auroras are a feast for the eyes on Earth. Yet while the northern lights may inspire awe, they usually don't shock or strike terror. But as the planet turns to the sun and night gives way to day, many Midwesterners are shocked when they wake with the dawn and see 3 suns rising in the east.
Imagine you're walking along, and there on your horizon, as the sun is rising up, suddenly there are 3 suns? What would you make of that?
It's like something out of a science fiction movie, but it's real. And what's even stranger is that multiple suns have appeared throughout history.
When ancient times, the heavens were the realm of the gods. Seeing 3 suns simultaneously, well, if you were about to engage in a battle, it could be an omen of doom.
Near this English field in 1461, 2 rival armies are terrified by the sudden appearance of 3 suns in the sky, until one commander turns the omen to his advantage.
The commander convinced his troops that these 3 suns were the symbol for his 3 sons, and so this was the sign that they would be victorious.
Inspired, his soldiers win the day, and the commander is crowned King Edward IV. But in ancient, medieval, or modern times, the question remains, what are these mock suns?
It's only in the last few hundred years that we've come to some understanding of them.
They are called sun dogs. And while they sometimes look like extra suns, they can also take on the form of an eye in the sky, or a halo. Sundogs and halos share a secret with lightning. Ice. But not ice crystals and thunderclouds. These crystals are found in cirrus clouds, and they're called diamond dust.
Where I grew up in Alaska, you could have the air itself, not just clouds, but the air itself filled with these tiny little crystals, and it's like the sky itself is filled with the dust of diamonds.
The secret of diamond dust is the way it's formed by water molecules made up of 1 oxygen and 2 hydrogen atoms. The 2 hydrogens link to the oxygen in a V shape. Then the V's form hexagons, flat, 6-sided shapes, like snowflakes. As light passes through these crystals, it's bent or refracted.
Refraction is the bending of light as it passes from one medium through an interface into another. When I put the pencil in, light will be coming directly to you from some of the pencil, And from the rest of it underwater, it'll have to bend as it comes out of the water. That will give you the appearance of the pencil being slightly displaced.
But in the sky, sunlight and diamond dust aren't enough to make a sundog. It also takes wind and gravity.
Imagine leaves falling from a tree. High pressure on one side of the leaf will push it up, creating a vacuum on the other side that pulls it. Eventually, that'll happen on both sides, and the leaves fall flat. Same with the crystals.
Wind and gravity stack the crystals like plates.
They're flat like this. And sunlight enters one edge, one side of this hexagonal plate, goes through it, and comes out two sides later. By doing so, it gets bent, but also spread out a little bit.
When sunlight refracts through these ice crystals at about 22 degrees, you can get mock suns on either side, or sundogs.
But air currents sometimes make leaves and ice crystals fall with one edge tilted down. When this happens, the crystals align at a different angle. And instead of mock suns, the refracted light creates towers called sun pillars.
Sun pillars are visible directly above or beneath the sun when it's low towards the horizon. Imagine a bunch of tiny mirrors above the sun, each reflecting the sun's light, and you get this pillar of light above and beneath the sun.
But is Earth the only planet where these strange phenomena can be witnessed?
The Earth is not alone in having an atmosphere. We are not the only planet with gases above us. Go to Mars.
Although Mars has an atmosphere that's only 1/100th as thick as Earth's, the red planet might have sundogs, formed by Martian ice crystals made up of both water and carbon dioxide. Back on Earth, the planet has kept turning, and several hours after the triple sunrise in the Midwest, in the Pacific Northwest, the sky blazes with another mystery. Light from space bent into forms that seem to defy belief. Our 24-hour tour of Earth's strange skies has reached mid-afternoon. And in a cloud, it looks like the spectrum has burst into flame. People call it a fire rainbow. But it's not a rainbow. And its fire is frozen. Its flames are made of ice. The same flat, six-sided crystals in cirrus clouds that generate sundogs make fire rainbows. But why do they look so different? Because the light from the sun is passing through the crystals at different angles.
There are similar processes that go into it as a rainbow, but it's not a rainbow because it's ice crystals and not raindrops.
With a real rainbow, the multicolored arch seen after a storm, the secret isn't ice. It's liquid water. Most people realize a rainbow represents all the colors of the spectrum, with rain acting as a prism. A process that starts 93 million miles away.
So now imagine you're riding a light wave from the sun that comes into our atmosphere, and it hits this shower of rain, spherical water droplets.
The light that goes into the sphere bends and breaks into different colors. But the colors can't make a clean getaway through the raindrop. They bounce off the back.
So there are some angles where light passes through, and there are some angles where light reflects. And in rainbows, we're seeing a combination of both.
Each color shoots out of the raindrop at its own specific angle. And out of millions of raindrops, only one color from each drop will line up perfectly with a pair of human eyes.
What we see as a beautiful rainbow is the end result of a long journey that light has made from the sun to our atmosphere, through those water droplets, and then to our eyes.
And no two people ever see the same rainbow.
If a group of friends spread ourselves out along the lake shore, each one of us is going to begin to see a slightly different rainbow coming up and going down in a slightly different place.
Everybody still sees the same pattern of colors: red, orange, yellow, green, blue, indigo, and violet, the Roy G. Biv learned by school children. But different conditions can bend the familiar into the truly strange. In rare instances, the light inside a water droplet is reflected twice, creating a second rainbow on the outside. In this double rainbow, the colors are reversed, like a mirror image.
You'll see a second rainbow centered on the first one, but now fainter because it had to go through a second reflection, and those colors, instead of red on the outside, will now have red on the inside due to that one additional reflection that the other light did not go through.
Sometimes, the conditions that create a rainbow-like phenomenon can be seen from a very different angle, from above.
If you've ever been in an airplane and you've looked out the window down on the clouds below, right at the shadow of the airplane, sometimes you can see a faint rainbow around it.
This colorful circle is called a glory.
A glory is an interesting phenomenon that I've photographed, and it occupies a small space of sky. And you'll see it when the sun is above you, looking down onto cloud droplets.
But there are other strange rainbows as the day comes to a close. Earth's atmosphere colors the sky by breaking up and scattering light waves. The air mostly scatters blue light, so the sky is blue for most of the day. But as the planet turns, the light waves travel longer paths through the lower atmosphere. Short wavelengths, like violet and blue, are scattered more, leaving the remaining light at sunset richer in yellow, orange, and red. That's why, very rarely, there can be a red streak across the sky.
the light is low enough and all the shorter wavelength light has been absorbed or scattered, you're going to have this overwhelmingly crimson, dark red, blood red rainbow. And I've seen one in the Yukon. It was one of the most spectacular sights I'd ever seen. I looked over in a valley and there was a red rainbow. In fact, it was a double rainbow. And it was very intense light, beautiful.
The sunset isn't the end of rainbows. Sometimes a moonbow might appear.
A rainbow with light that comes not directly from the sun, but reflected off the moon. And a moonbow will appear as white to the naked eye because it doesn't have the intensity for us to see the colors in it. But if you have a camera that's sensitive enough, you will indeed see that it's a regular rainbow.
The moonbow is a creature of the night. But in the final moments of daylight, there's a final gift from the sun that some people spend all their lives looking for and never find. After 12 hours of light and amazing sights from a triple sunrise to a scarlet rainbow, half the world watches a familiar sight, the sun sinking into the west in a symphony of yellows, oranges, and reds. But in rare instances, just before the sun vanishes, another color breaks into view, a flash of green.
When that occurs, the viewer may see very briefly for less than a second to maybe 1.5 seconds long what appears to be very brilliant green, a very pure green light.
Blink and you might miss it. The green flash is so mysterious, so elusive, that skywatchers can spend years watching for it and never seeing it.
I myself have spent my entire life looking for one. First time it was from the deck of a ship crossing from Spain to Barbados. I happened to look off towards the west, and just as the last moment of the sun disappeared below the horizon, I saw it turn to green. I yelled, tried to point it out to people, but by the time I could call anyone, it had ended.
But while some people insist they've seen the green flash, others insist that it's nothing but a myth. To follow all of your favorite shows on the Weather Channel, go to facebook.com/Weather Channel Originals. we continue our journey through the strange skies of a single day on Earth to find a flash of green that some say isn't there.
I think a lot of people feel that the green flash is just a myth because some people see it and some people don't.
It just sounds so outlandish to them that the sun, which is normally red at the horizon, should suddenly appear green. They absolutely reject the idea and can't believe that that's possible. From the very moment I read about green flashes, I thought, wow, what a neat phenomenon. I've got to go see this stuff. And I looked for it for years and years.
The secret of the green flash begins with refraction, the way the atmosphere separates light into different wavelengths or colors.
When the sun is setting, it's actually a spectrum of colors. And the red is lowest, the orange is next higher up, followed by yellow, green, blue, and violet.
As the sun goes down, the colors at the top of the spectrum and absorbed by the molecules and particles in the atmosphere. They disappear. Then, as the sun drops below the horizon, the bottom colors, the yellows, oranges, and reds, disappear too. But when the top and bottom of the spectrum vanish, there's still the color in the middle.
And you see a little lingering bit of green as the last part of the sun sets.
But the green flash can be blocked from view if there's too much dust or other material in the air.
To see a green flash, ideally you need a very clear sunset. No pretty pink stuff.
The best time to see the green flash is when you have a completely flat horizon with no clouds at all. In other words, a boring sunset. So when you have that incredibly flat horizon with the air is still, that's the time to look.
But with the right sunset and the right timing, the green flash turns out to be no myth, but a reality. Although the green flash usually lasts only a second or two, a change in altitude or angle can sometimes result in seeing an additional flash. Sometimes a quick climb up a hill can be rewarded with another flash of green.
Or even stand up from a sitting position. So you have a second or two to stand up and catch the flash again.
At extreme angles, there can be more extreme views.
On the summit of Mauna Kea in Hawaii, I photographed a triple green flash. Just kept shooting. So it's just a progression as the sun is setting relative to me at that time, going through just the right atmospheric conditions to produce not one, not two, but 3 green flashes.
But sometimes, eager photographers think they've captured a green flash, but find it's eluded them. The secret of the disappearing flash is that staring at the setting sun can create a false green light. Look at this red dot. Stare at it for a count of 20. As you stare at the dot, part of your eye that senses red is getting overloaded. Now, look at a blank surface, and you'll see a blue-green after image, if you're not colorblind. In the same way, staring too hard at a setting sun can create a false green image, when the sunset is really still yellow.
At sunset, after images can affect the color that you see. And if you snap the shutter as soon as it looks green, you tend to get a yellow flash on film. So I've learned how long to wait after I see the green before I trip the shutter.
On only 3 times in all of my life of looking at the setting sun have I ever seen the green flash, and never when I had a camera.
Unlike other phenomena like the aurora or sundogs, the green flash may be something confined to the strange skies of Earth.
There might be green flashes on other planets, but probably not in our solar system.
A planet with a thinner atmosphere, like Mars, has less light refraction and less colorful sunsets. But if the atmosphere is too thick, as on Jupiter, the clouds would block the rays of the green flash. But on Earth, for as long as there are sunsets, some people will continue to seek the green flash on the horizon.
They're so beautiful. They're gorgeous things to look at. The color that you see in a green flash is so much purer than the color you see in a rainbow, for example. When I was photographing green flashes regularly, I would come back from a sunset, and every time I went through a green traffic light, I would think, gosh, that looks pale and feeble compared to what I just saw when the sun went down.
The sky that stretches from our feet to the edge of space shows wonders to those who...
Since the dawn of humankind, people have looked up at the sky and seen lightning, auroras, and rainbows, and solar halos, and wondered about what is it that produces these things.
The sky is filled with all sorts of strange phenomenon. If you simply take the time to look up, you can see an entire universe of new phenomenon.
And a good evening, everyone. Meteorologist Mark Thibodeau, thanks for staying with us. Still tracking Hurricane Maria, brand new advisory, 11 p.m. Eastern Time. Not much change overall in strength or wind speeds. Currently 125 miles an hour, still a Category 3, a strong Cat 3. Moving off to the north-northwest at 9 miles an hour. Latest computer guidance very similar on where Maria will go as we head through the weekend into early next week. Off to the north a little bit. It's expected that a trough of low pressure developing across the Midwest will eventually curve it away from the United States. Expected to remain a hurricane all the way up into the northeastern U.S. Offshore, more than likely. Latest computer guidance pretty convergent on taking it up to the north and then curving it out to sea as that trough of low pressure over the Midwest begins to catch up to it. So here's what we're looking at in terms of the main risk from this. It's going to be rip currents all the way from Nantucket straight down to Ocean City and points southward through the weekend.
We have uncovered a remarkable planet, a world of extreme weather, alien landscapes, and bizarre phenomena. It's the most complex system we know of in the universe. That planet is Earth, and we are only beginning to unlock its secrets. Earth is being invaded by aliens. From the swamps of Florida, where many believe a hurricane let loose a monster.
There's one up ahead there. That's a python. It's a big one, too.
To a frankenfish cruising the Potomac.
There it is. There's a huge one.
Wild hogs tearing up the state of Texas.
They can consume just about anything that they can get their mouth on.
And swarms of killer bees invading America.
Your body will be producing so much histamine that it's swelling itself to death.
Around the globe, animal invaders are on the move. How did this happen? And is there anything mankind can do to turn the tide? Earth is under attack, and mankind is struggling to fight back. Animal invaders are steadily taking control of ecosystems worldwide. With no natural predators in their new homes, they are outcompeting native creatures for food and territory. The force behind this outbreak is mankind itself. Globalization has linked the world, and animal invaders have come along for the ride. Ships accidentally transport aquatic invaders on their hulls, or pet dealers import exotic snakes and reptiles that later escape or are released into the wild by their owners.
The natural world has its own checks and balances, its natural selection. Man has changed all of that. We can take a single animal from one end of the United States to the other.
Florida, the Everglades. Here, in the mysterious 2 million acre landscape of swamps and mangrove trees, a hunt is underway for the largest and most feared invasive species in America.
We are road cruising for Burmese pythons out in the middle of the Everglades. There's a magical time period, usually right around dusk, that we like to call prime time. And that's when something happens where all the snakes decide it's time to come out onto the road and cross.
The Everglades Burmese python is one of 50,000 invasive plant and animal species in America alone. In 2012, the U.S. government spent $2.2 billion trying to control or eradicate invasives across the entire country. Because predator and prey evolve together in an ecosystem, when an animal invader gets dropped in a new habitat, there are rarely any predators equipped to prevent a population explosion. Native to Southeast Asia, the Everglades Burmese python is the prime example of the invasive species problem. In Florida, it found a subtropical climate similar to its native habitat. And it's great at two things that make an animal invasion hard to control. Reproduction. A female can lay as many as 100 eggs in a single breeding season. And hunting.
So this is an adult Burmese python. She wants to get away from me, but I can kind of keep her around me if I grab her tail and pull back. She doesn't like that though. It's ready to strike. It's got its neck coiled back, so it's got the potential to straighten out and go for me.
Despite this deadly potential, the Burmese python is one of the world's most popular pet snakes.
They're actually really nice, sweet, docile pets. The problem is they get 8 or 9 feet long. When you don't have the capability to take care of this animal anymore, people release it and they become an animal invader.
The Everglades pet python invasion began in the early 1990s. One theory points to an accidental escape in 1992, when Hurricane Andrew, a Category 5 storm with 150-mile-per-hour winds, flattened an exotic pet breeding facility near Homestead, Florida.
These are animals that have no natural predator in the state of Florida. This is the 5th largest snake in the world. These can eat a lot of the native Floridian wildlife. Anything from birds and reptiles and frogs, all the way up to alligators.
A rare encounter between a 12-foot python and a 10-foot alligator is caught on tape. In this fight, the snake takes on more alligator than it can swallow. The battle is a draw. Pythons have become such a problem in the Everglades that state and federal officials have deputized private citizens to capture or kill them.
When you're looking for pythons, one of the things that I like to tell people is look for what looks like a speed bump up ahead.
With at least 25 species of snakes in the Everglades, the hunt can become a game of reptile identification.
It's like we got a little brown water snake here. You can see they kind of have a patterning really similar to a python. This is a eastern garter snake, mangrove salt marsh snake, so not our quarry for the evening.
These difficult-to-hunt snakes are themselves brutally effective hunters.
We got teeth all along right there and on the inside, too. They're mostly covered by mucous membranes now, so they're hard to see, but lots of teeth.
When a Burmese python bites down, rows of backward-facing teeth seize and hold the prey, preventing escape, while the snake slowly begins to swallow it whole. Moving in for the kill, the python reveals why it belongs to the family of snakes known as constrictors.
If I was a prey item, this is what it would be feeling like as he's trying to take me out in order to eat. They bite the animal, they throw the coils around, they start to constrict, shutting off the blood supply and the oxygen supply to the brain, then they get swallowed whole and slowly digested. And there he goes across the windpipe. Jules?
We have tried trapping the pythons unsuccessfully. No one so far has been able to develop a trap that can attract pythons. So right now, we don't have anything in our toolkit as invasion bombs manage the population.
To date, the only effective control tactic is the small army of volunteer hunters who cruise the roads from the edge of the Miami suburbs to the deepest parts of the Everglades.
We've been out here for a couple hours and no pythons yet. They're usually a late night animal. Oh, there's a python. That's a python, it's a big one too.
An army of animal invaders is marching on ecosystems across planet Earth. When humans relocate creatures from their native range to a new habitat with similar weather, the damage can be catastrophic. In Florida's Everglades, the largest invader is the Burmese python. And the best way to catch one is night hunting on park roads.
Oh, there's a python. That's a python. It's a big one, too. This is a subadult. It could be an adult male Burmese python, but it's probably an immature female. With a python, you have two ends. You have the end that tries to bite you, and you have the end that, poops all over you.
When threatened, Burmese pythons deploy a secret weapon, musk.
That's the smell of victory right there. It just smells awful, and it's something that they're gonna use to kind of dissuade animals from messing with them. So we're gonna actually bag it up here. Now, you wanna make sure when you drop them here, you don't let them grab you. So they bite, ready, set, go.
Got it.
All right.
With Everglades population estimates ranging as high as 100,000 Burmese pythons, hunting is having little, if any, effect. In 2013, Florida's Fish and Wildlife Commission sponsored a month-long python challenge. It attracted 1,600 hunters and netted just 68 snakes. A python invasion. Biologists still can't predict how much the snakes